Now let's move on to the second part of the chapter, data types. And this is also a very important thing because when you have the data available and you need the right tool to process your data. So the first way people look at the data is that they classify them as either qualitative or quantitative. Each data type will has its own statistical tools to use. For qualitative data, sometimes we call categorical data, if the data consists of names, labels, and importantly, it's not represent counts. Okay. So for example, we talk about gender, male, female. It's just a name label, right? Male, female, race, Asian, white, black, names label, right? Not represent count. Religion, Christian, Buddhism, Muslim, marital status, married, single, divorced. Even say that the short number of player, right? Soccer players. Even it's a number, but those number is not represent counts, right? We have a short number 7 and a short number 8. Basically, it's just used to recognize different players, right? Yeah, it's just a kind of labels. So this is a bit more tricky, but that not represent counts, right? We don't say like we don't have something like the 8 players is doing better than the 7 player, right? Number 7 player. And then the quantitative data, which is numerical data, it consists of numbers representing counts like age, right? 78, 80. So we know that an 80-year-old person is older than the 78, right? Height, 5'8", 5'4". So the 5'4" person is shorter than the 5'8", right? Weight, 100 pound, 120 pound. Income, test score, right? So this is called quantitative data, numerical data. So for quantitative data, we can classify them a little bit further by either discrete nature or continuous nature. So discrete here is a data that the kind of quantitative data with values are finite and countable. So for example, number of tosses of a coin before you get in tails, the first tail. So here maybe you should do 1 toss and you get the first tail. And you do 2, someday you do 3, 4, 5, 6. Maybe one beautiful day, you toss a coin 1,000 times, you still not find a tail. It may happen, right? A number of emails inbox each day, maybe 0, 1, 2, 3, 4, 5. So it's a count in nature, right? Chop, 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 chop. And then for continuous data, in this case, it is a quantity data, but with value are infinite, are not countable. So for example, length of tables in classrooms, right? So you can have table with maybe 3 feet long, or 3.1, or 3.2, right? Something like that. Yeah. A temperature range during the year in Chattanooga, right? So we may have like days with 94, 95, 96, but if you have a very accurate thermometer, you can see it can be 94.1, 94.2, 94.3. So the difference here, basically, like for the continuous data case, is basically you can have the decimal, right? The decimal does make sense. And the discrete, in this case, the decimal does not make sense. So this figure, it tells us how data can be classified either qualitative or quantitative. And if the quantitative, it can be further classified discrete quantitative or continuous quantitative. So let's look at the example. A survey is conducted to learn the actual miles that an electric car can ride after full charge. So in this case, the type data we get will be the mileage, right? the car can drive. So this is a continuous quantitative data type. And why? Because the measure in miles is a numeric value. It's not category. So for sure, it must be quantitative, right? It does represent count, right? 5 miles, 6 miles, 300 miles, 300.1 mile. And it can take any value, right? Including decimal. So for example, like it may be possible, if you have very accurate um, way to measure how long the car can drive, right? It may happen like the car will stop at 247.5 miles, right? At 247.6 miles. So now we have the quiz here. This quiz will help you to understand better about the nature of data. We can classify in the first one, strategy, qualitative, quantitative. So what data type of the following? So let's just go through one by one, right? Temperature at a region. Oh, we did have that, right? Chattanooga region, right? Any region, right? So it's either quantitative, right? Because it's a number. The number represents count. 94, 95, 60, 0. And it can be decimal, right? The decimal makes sense. So it will be a continuous quantitative, right? How about satisfaction level rating? Not satisfied, satisfied, and very satisfied. So in this case, you can see that the data here doesn't have number. No, right? If it doesn't have number, a number does not represent counts, right? In that time, it's just qualitative, right? It's just a label here. Number of days per week a student each lunch school lunch. 0 day, 1 day, 2, 3, 4, 5, 6, 7, 8. No 8, right? So here you have number represent count, right? You have can you have something like 5.1 day? No, right? So if you don't have that, it will be discrete, right? Discrete, quantitative. So if quantitative, it has to be classified further, right? Discrete or continuous. Mileage of a used car, right? So in a used car, you have a mileage, right? But um, you see it had number, right? Represent count. Quantitative, which is quantitative, right? Yeah. Discrete or continuous. So if you just look at the odometer, you may see maybe you don't have the decimal thing, right? But in fact, if you have very accurate odometer, right, you may have a car which already have 700 miles, maybe 7.1 mile, right? So it's a continuous, right? It makes sense to have 700.1 mile and 700.2, right? Number of customers waiting in line, 0, 1, 2, 3, 4, 5. So it's a quantitative, right? You have number here, represent count. But then again, you ask yourself, can we make a decimal here? 5.5 customer in this line. Oh, it should be right. So it will be discrete, right? Discrete. Discrete. So for qualitative data, we have a quick way to look at it by using visualize. The first type of graph we can use to visualize is called bar graph. So it helps to depict the frequencies of each category of the data. And sometimes you don't use frequency, but you use percent. So in the x-axis will be the categories, and the y-axis will be the frequencies of each category or the percent of each category. So here in this plot here, you can see that the school, before they open, they decide to build a uh, sport complex, right? And then basically, like, they need to survey the student, right? What kind of sport they want is their favorite, right? And here you can see that more than 15, about 16 of them love basketball in the sample. About 10 love rugby, and we have some love football, about 12 or something, and then tennis and golf, right? So based on this survey, they will try to design in such a way, it's optimized in terms of the um, economy, and in terms of, it also meet the expectation of the students. Another kind of chart, also very popular to work with the qualitative data, is a pie and donut chart. So here it helps to depict the percent of each category as slice as a circle or donut. So if you use circle, we have pie chart, and if you use a donut, you have the donut chart. Okay. So here the size of each slice here is proportional to the frequency of the category. So if you have bigger slice, which means you have more uh, come from that category. And you can see this kind of chart is very popular in different meetings and conference and news. Right? So here, like, we have two figure the pie chart for the kind of boat was stolen in Florida. And from here, you can see the jet ski motorboat. They make a big segment and this among all these stolen boat, right? And we have less from sailboat or inboard fishing. And the electric vehicles share, the sales share, uh, you can see here that we have the more from the Tesla Model S, about 39%, and then come second is Chevrolet and Nissan, it kind of ties 16 and 15%, and then you have other category as well. So let's look at another example where you can see the picture more in a more complete way. So here, like, the enrollment data from two different college, De Anza and Foothill. So in De Anza, maybe just focus on De Anza. Okay, Foothill just the same. So De Anza, you have they have like they keep track, right? They have about 9,200 students in their school with full time, right? And part time is 13,296, and in total they have like 22,496, right? And you can translate it to percent of full time, which is 9,200 divided by the total, and you get a 40.9%. And the part time you also have, which is the remaining 59.1%. And from here, we can make a report, right, by show the table and also use a visualize, right? So the visualize, you can see, uh, you can have either the pie chart, where the yellow segment of the Anza College is a part-time student, you have 59.1%, and the purple one will be full-time, 40.9%. And the same thing, you can also make the bar graph, right? Bar chart, which is you have the lower column, 9,200 for the full-time, and the part-time you have 13,296, right? Similarly, for the Foothill College, right? You can also have the table, and you also have the bar chart and pie chart. Now, let us look at another way people also use to classify data, yeah, based on its level of completeness. So here, people sometimes they classify data, they don't use quantitative or qualitative, but they prefer to use nominal, ordinal, interval, and ratio, because this will give you a sense about how completeness of your data is. So first type data, which is the most basic kind of data, whatever kind of data, whenever you can record it, and we call nominal level. So it has a name, labels, numbers, but cannot be arranged in some order. So here, like, we have race, right? Which is Asian, white, black, Hispanic. I say again, search number of soccer players, right? So you have a label here, which is number 1, number 2, 3, 4. But for sure, we cannot arrange them in order, right? We cannot say number 4 doing better, number 3, right? Maybe number 4 doing better than number 1, right? Number 4 player doing better than number 1 player. And then the second level of completeness, which is, we start from a nominal level where the data have a name and label, okay? So as long as you can record it, it's a nominal for sure. But whether, it has more property and it will move up to more complete level. So for the ordinal, it's a nominal, but it can be ordered, okay? But in this case, we cannot take a difference between data values. It meaningless when take a different. So for example, if we talk about the cost rate, right? A, B, C, D, E, F. So if person get an A, which is that person do much better than person get an F, right? ID. T-shirt, right? T-shirt size, small, medium, large, extra large. You can order that, right? Small is much smaller than extra large. Medium is smaller than extra large, right? But you cannot take a difference. You cannot do A subtract F or small subtract extra large, right? So before we move to two other kind of completeness of data, let us look at the definition of true zero, natural starting point. So true zero here means that the value zero means none of what you measure or nothing at all. And we also say data with a true zero is the data has a natural starting point. So let's look at this table on the left-hand side with the time data has true zero and right-hand side no true zero. So if we talk about money, right? How much money you have in your bank account? If you have $0, so which means you have no money, right? The weight, right? How much gold you have in your house, right? 1 kilogram, 2 kilogram, a euro, right? So for me, I have euro. So basically, it has no weight, which means it represents no weight, right? No gold. Number of pets you have, right? Zero pet, which means you don't have any pet, right? So this kind of data, we have the data with the true zero. So zero just means nothing at all. In the no true zero data, so for example, we talk about temperature, right? Celsius or F, right? So a 0 Celsius, it doesn't mean like there's no temperature, no heat. So 0 Celsius, it just means like it's just a mark, right? Which means where the water is turned from the liquid to ice. The year of 0, it doesn't mean no time, right? No year. It should mean the mark, right? So we are 2025. So which means we are 2025 year after the mark 0, right? IQ score, so say, if we get an IQ score of 0, it doesn't mean you have no IQ, right? And no intelligence. It's a mark, a kind of marker, right? Mark. So which means like, it's just a mark, right? Mark like 0, get 0 point, right? So say if you make just the multiple choice and all wrong, right? So from that, the quick tip here is true 0 data is that the 0 means nothing at all. So you ask yourself, right? Is it mean nothing at all without 0? And no to 0 is that basically like the 0 here will still means something, right? Let's look at two different level of data, which is interval and the ratio. So for interval level is the ordinal level of data, but the difference between the data values is meaningful, okay? Which we have equal, sometimes we call equal spacings, but we don't have a true 0. So examples here is temperature, right? Either in C or F. So here in this case, you can see we have label, right? Because we can record it. So it's a nominal for sure. It can be ordered, right? 0 and a 10, they're different, right? 0 is much cooler than 10, right? And then say you can take different, right? So if you have 0 Celsius and 10 Celsius, the difference will be 10, right? 10 degrees. So 10 degrees, 10 Celsius is 10 degrees warmer than 0, right? And again, this data doesn't have true 0, right? zero success doesn't mean no hit, right? It just means like just a marker, right? And the marker here is just the when the water changes status. Calendar years here is interval data as well because it have label here, right? Years 1, 2, 3, and it has an order, which means you can it's certified ordinal level already. Like you can order the year, right? And then also like you can take different, right? So we are at 2001, 1900, right? They are 100-year different, right? And again, year zero, it doesn't mean no time, right? It's a marker. It's a marker. And then the ratio level, which is interval level and data type, and with true zero. So like length in meter, right? Uh, how far your car can drive, right? In meters, say, uh, after a full charge, right? Our electric car. And another time, you can see that it satisfies all the property of interval, right? You can take a different. It has a name, it has an order. But again, here, like the zero here, I mean, just no length, right? Basically, if your car after full charge, it can drive 0 meter, right? So which means it cannot drive, right? No length. The revenue in dollars, right? Again, you see the interval, you can check all the property, and a $0, which means it have no revenue, no revenue. So we can use this table to check, the completeness of your data. Is it like categories certified or not? So often, as long as you can record, it's always the categories always certified. You can always check for all kind of data. Can we rank it or not? If you can rank, and it shouldn't be belong to nominal, right? It must be belong to either the other three category, ordinal, interval, ratio. And then can you take a different? You have equal spacing property. Yes, so that there must be either interval or ratio. And then again, the last one, 2 0, right? Does the zero mean nothing at all? If yes, and then just it will be ratio, right? Ratio. So we can use the table to check its completeness. So here an example about electric car full charge again, right? So this is ratio data because why? Because as long as you can record it, it has the category certified check, right? Rank order, if the car after full charge do 300 miles and a car after full charge do 100 miles, so we know that the 300 mile do better job, right? Equal spacing, which is you can take different, right? 300 miles and 100 miles different in 200. And 2 0, a zero, which means after full charge, it cannot ride. So the ratio data, right? So let us look at this quiz together so we can get a better understanding about how we can classify the data, okay, in using the 4-level measurement. Temperature of a cup of hot chocolate every 15 minutes until it reaches the room temperature. So here, like in this case, you can see the temperature, right? Temperature data. So temperature data, in this case, you can see that it has a name, which it has a label, right? It has the rank order, right? A cup of coffee 100 F is hotter than a cup of coffee at 7F, right? That's 70F. And then can you take a difference? Yes, right. We can take difference. The zero here mean no heat at all. No, right? So in this case, it will be interval data with the first 3 properties certified, but the zero here is doesn't mean no hit, right? So in this case, it will be the interval, right? Interval for this case. School has closed or not during lunch. So the data will be yes or no, right? Closed, not closed, right? So you can see here is the categories, closed, not closed, right? It has label. Can we rank it? The close better, not close, or something like that. If it doesn't make sense to order that, right? So it's indicate it doesn't make sense to. It doesn't mean that close is better or not close, right? We don't have that kind of ranking, right? So if we don't have this kind of ranking, which is the second property validated, so it must be nominal. Nominal. For class rank, freshman, sophomore, junior, senior. So in this case, you can see that it had a label, right? So first certified, you can rank it, right? You know that a senior person, he older than, at least in terms of class, right? A freshman person. So it's an ordinal. Number of days per week a student eat school lunch. So you can see here, category, right? 0 day, 1 day, 2 days. So you can label that. You can rank it. A person do eat 3 days a week, do more school lunch than a person do 1 day a week, right? Equal spacing, which you can take different 2 day and 1 day, different 1 day, right? And 2-0, a person who eats 0 days a week, which means they don't have lunch school or school lunch. So this way is a ratio. It's a more complete of data. And the more complete of your data is, it's more statistical tool available for you.